Is Algebra 3, Lesson 20. Starts off in your book on page 145. We're talking about two special triangles, specifically two special right triangles. You should have learned about this before you came into this class, right? Those two special right triangles are a 30, 60, 90 right triangle and a 45, 45, 90 right triangle, correct? We should know what those ratios are. I'm going to put them in most basic terms. A side opposite of 30 is x. Okay. Let's see. The side opposite of the 90 is 2x. And the side opposite of 60 is x radical 3. Okay. I could call it 1, 2 radical 3, but I'm going to leave it like this. Okay, so that you understand it. On our 45, 45, 90, opposite of 45 is x because it's isosceles. Opposite the other 45 is x. And then I have x radical 2. Okay, or 1, 1, 1 radical 2. Okay, but this way it doesn't matter what I plug in. What's most important is what's going to be opposite of 30. That's where we want to start from and go from there. Does that make sense? Are we familiar with our right triangle ratios? Okay, if you're not familiar with them, you need to write them down. You can also write it down as 1 radical 3, 2. Okay, and over here, 1 to 1 to radical 2. Okay, but that's your most basic ratios. Okay, I don't want you to get so stuck on those bottom ratios because people who get stuck there can't solve any other questions. All right, do we have these? Okay, good. Because question number 1 is going to say, draw the necessary reference triangle to evaluate 2 radical 2 over 3 sine 45 degrees. Okay, so what's that? Yeah, and it says do not use a calculator, which we can solve this without a calculator. Okay, let's see if I've got, here we go. All right, so what I'm going to do is I'm going to erase some things in here. I'm going to get rid of the 30, 60, 90. It needs me to draw a reference triangle. Okay, so that's my reference triangle. Okay, I can make it any size, any orientation, but that's a 45, 45, 90 triangle. Okay, and what they're describing to me is, well, yeah. Okay, sine of 45 degrees. Okay, what is sine? What does sine stand for? Okay, sine equals opposite over hypotenuse. So whenever they say use a reference triangle, we are using the 1, 1 radical 2. Right, so 1, 1 radical 2. So sine 45 as a ratio, okay, we just need to pick a 45-degree angle, right? Okay, so what is sine of 45 degrees in a 45, 45, 90 right triangle? What's opposite? What's opposite? 1. Okay, opposite over hypotenuse. What's my hypotenuse? Radical 2. So what they're showing me here is 2 radical 2 over 3 times sine 45 degrees. What I'm doing is I'm substituting in the ratio of sine 45. Okay, so what I'm going to end up writing here, let's see, I'll just do it down here, is I'm going to write 2 radical 2 over 3 times, okay, and what I probably want to go ahead and do with this, does anybody see what's wrong with sine equals 1 over radical 2? I can't have a radical in the denominator, but how do I fix that? Multiply by what? Multiply by radical 2? Over radical 2, right? Something equivalent to 1. What's that give me for an answer? Radical 2 over 2. Okay? So this becomes the question that I'm working with. 2 radical 2 times radical 2, right? 3 times 2. All right, so what is 2 radical 2 times radical 2? 4. 4. 4, because radical 2 times radical 2 is 2, and 2 times that 2 is 4. All right, what's 3 times 2? 6. So I get 2/3 as an answer. Okay? Now, it said to use, did we need a calculator to do that? No, but could I use a calculator to check it? Okay? Yeah, we can use a calculator to check it. Now, we do have to be careful because this is a complex numerator. All right, so what I'm going to do here is we're going to do 2 square root of 2, okay, divided by 3. Okay, that gives me that. And then I'm going to write, times sine 45. Now, hopefully, I'm going to check my mode first. Nope, my mode is in the wrong thing. It needs to be in degrees. Okay, and I should get 2/3. 2/3 is represented here by 0.6 repeating, but in my graphing calculator, I can hit math fraction, and I get the 2/3. So can I use a graphing calculator to check my answer? Yes, but if on a test I just wrote 2/3, do you think you're going to get credit for it? No, you need to be able to draw the reference triangle, right? From the reference triangle, you need to be able to get the ratio, right? Then you need to be able to show me that you can multiply radicals, okay? All right, does all that make sense? Okay. All right, let's go from there. We only have 3 questions, which is good because we don't have a whole lot of time. All right, this says evaluate sine 90 minus cosine 240 plus sine 150 plus sine 270. Do not use a calculator. All right, this is how we do this. All right, sine 90. Well, 90 degrees shows up right here, correct? Right, there's no reference triangle to draw from that. Okay, what we're working with here is what is called unit circle. So I'm going to give you this if I haven't already given it to you before. It'll be a refresher if you've already gotten it. But sine equals the y-axis. Okay, cosine equals the x-axis. Okay, so in a unit circle, things are given in terms of units of 1. Okay, so on the x-axis, if we look at these parts, there's 4 different points that we could be on an axis, okay, in terms of a unit circle. All right, this is -1, this is 1, this is 1, this is -1, okay? These green dots represent points on the x-axis. These red dots represent points on the y-axis. So anytime they say evaluate sine and it shows up on the y-axis, it's going to be either 1 or -1. Okay, you follow me? All right, anytime they ask for cosine and it shows up on the x-axis, it's going to be either 1 or -1. Now, if they had said evaluate cosine 90, right, the y-axis represents 0 to the x-axis. Okay? So if they said cosine 90, it's 0. If they said cosine 270, it's 0. Right? If they said sine 0 degrees, what are we looking at, Christian? Close the Chromebook. Okay? If they tell me cosine 0, it's 0. If they tell me cosine 180, it's 0. Or I'm sorry, if they tell me sine 0, it's 0. If they tell me sine 180, it's 0. Does that make sense? All right, so I actually don't have to do all that much work to get sine 90. I know that sine 90, because it's here and it's positive, is 1. You got it? Okay. Now, for this next one, okay, and I'm going to make a little coordinate plane for each of these. It says 240 degrees. Remember that this is my initial side. 240 degrees is coming around, but it doesn't come all the way to 270, right? All right? So it comes here, and I always draw my reference triangle in relation back to the x-axis, never to the y-axis. Okay? So just so that we're clear, anytime I have to draw a triangle and it shows up on the coordinate plane, it should look like one of these 4 triangles. Okay? With right angles here, 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 there, and there. Okay? It should look like a wing on a butterfly. Okay? Now, if you ever draw it and it looks like part of an hourglass, okay, that's wrong. Okay? Think about this. I don't know if this will help you, but this is the symbol that you would see on the back of a black widow spider, right? It means death. It's wrong. Okay? So you want to think butterflies and not spiders, okay, when you go to draw these triangles. All right. So I have this right here. It's cosine 240. So the next thing that I need to know is I need to know what my reference angle is. All right? In this case, it's how far past 180 have I gone, okay, which should be 60 degrees. So if this is 60, then this is 30, right? Okay, so as I begin to set this up, right, this is going to be -1, negative what, radical 3, and 2. Okay, so it says, what is cosine of 240? Well, cosine is adjacent over hypotenuse. So I want the adjacent part to my reference angle, which would be -1, right, over hypotenuse 2. So I've got 1 minus 1/2. You with me so far? Okay. All right, then we're going to have sine 150. Okay, so we're going past 90, right? We're going to wind up over here because we're not quite to 180. In fact, we're 30 degrees off of 180, correct? All right, so I get that. So that's going to be 1. This is going to be negative radical 3 and 2. Do you guys understand why I've got a negative over here, here, and here? All right, because of where we're positioned on the coordinate plane. Okay, so the values are the same, the 1, 2, the radical 3, but they're negative based upon location. All right, so it says sine of 150. So we're going to go from our reference angle, which in this case is the 30-degree angle, and we're going to find sine. Sine is opposite over hypotenuse. So that's what? Plus what? What's opposite of 30? 1. What's hypotenuse? 2. Okay. Finally, we have sine 270, which brings us back to our earlier point. Okay. We're right there. Notice that it's sine. What is sine at 270 degrees? -1. Very good. All right. So now we just need to figure this up. Well, 1 and -1 are going to cancel out, right? Okay. Now I've got positive 1/2 plus 1/2. So my answer should be 1. Okay? You can use your calculator to check this. If you're already in degree mode, you can type it in. Sine 90 minus cosine 240 plus sine 150 plus sine 270. Do I get 1? Yes, I do. So my calculator can check it, but a calculator should not be my work. Was that part of your question? Yep. Got to show those triangles. Okay? Use the calculator to check your work. Now, if you're taking the ACT, what should you do? Use your calculator. Okay? Question number 3 is the same type of question, and you end up with C as an answer. Okay?